This video is a direct follow-up of the previous one. We're going to finish looking at all of the possible symmetry combinations that a strip pattern might have. Our next combination are strips like this one, and these two strips have every kind of symmetry except for a horizontal flip. In other words, there are translations, glides, vertical flips, and half turns in both of these strips. The translation unit in both of these is the first 4 footsteps, and I can see that in the top pattern pretty clearly because I have these first 4 footsteps arranged in a U going up, and then they go down, and then they go up again. The second pattern is a little bit more subtle and harder to understand because it doesn't have as much space between the basic left footprint that is driving everything. This second pattern is basically a set of 4 footprints that can be described as a downward-facing left footprint, an upward-facing right footprint, an upward-facing left footprint, a downward-facing right footprint. And then we've got the pattern backwards, and then the pattern repeats again. In other words, the translation unit is these first 4 footprints, and they don't go to here because the footprints don't match up. They have to go all of the way to there. And in the second pattern, the same thing happens. Our basic piece is this, but we can't just translate it to there because the footprints don't match. We have to translate it all of the way to here. Now, what this basically means is that we have a very long basic translation. Now, in both of these things, I want to stress that there's evidence of a glide in just looking at it. If I'm looking at this upwards facing U, followed by a downwards facing U, followed by another upwards facing U, is a sure dead giveaway that there might be a glide. In the second pattern, it's a little bit harder to see that there's a glide, or rather, exactly what the glide looks like, because this first footprint might glide to here, or it might glide all of the way to here. And so the glides have to be investigated just a little bit more carefully, and in order to investigate that, I want to add the horizontal line that is the glide line. So I've done that, and now what I want to do is I actually want to think about how a glide is going to take these first 4 footprints. Well, with a glide, I always flip the image and then I translate. And what I want to notice is that this is exactly half as far as I had to go with the full translation. In other words, there's evidence that the glide length is half the translation length because I'm only going from this footprint to this footprint. Same kind of thing happens down here. If I do the glide on the first 4 footprints, I flip and slide, and everything matches up. And again, the length of the glide is from here to here, which is exactly half of the length of the translation, which would take this footprint all the way to that footprint. So we've discovered something important. The glide is half as long as the translation. But there's another thing that I also want to think about these glides. If I do the glide twice in a row, it looks like this. I first of all flip and move. That's my first glide. And then I flip again and move. And the net result of 2 glides on this top strip is just the basic translation. It's taking these first 4 footprints into the ones they are translated to. Similarly, in the second pattern, we do 2 glides in a row as follows. We flip and glide. We flip and glide a second time, and 2 glides in a row makes the initial set of footprints go all the way to the ones where they are usually translated to. In other words, it's important to understand that 2 glides in a row equals the basic translation. Now, I also want to look at some other forms of symmetry. It turns out that there's some obvious vertical symmetry. If I draw lines between the pairs of feet where the toes are facing each other, there's obvious vertical symmetry. And same thing in this second pattern. There's vertical symmetry across lines drawn between the pairs of feet with that have facing toes. And it's because this foot reflects into that one. If I look over here, this foot reflects into this one reflects into that one, this one reflects into that one, and the whole strip reflects on itself. Now, in this second strip, I might be inclined to think that there's another line of symmetry right here. But it's important to understand that this line is not a vertical mirror. If I were to reflect this foot across that line, this is a downward facing foot. And so when I reflect it across a vertical line, it would stay a downward facing foot. But this foot is an upward facing foot. So this green line is not a vertical mirror. The vertical mirrors only happen between pairs of feet that have facing toes. Let's draw those lines. So here are the lines. Now it's important to understand something else here. The vertical mirrors are trapping sets of 4 feet. These 2 feet are part of a pair and the other pair is off the paper that way. These 2 feet are part of a pair and their other 2 feet are off the pattern that way. But we get these mirrors between sets of 4 feet. And inside one set of 4 feet, there appears to be a half-turn rotocenter, because I can rotate those 4 feet in a half-turn and they land on themselves. And this would actually be a rotocenter for the whole strip, because this block of 4 feet would land over here and this block would land over there and so on. Same thing happens in our second pattern. If I look at these 4 feet, I can rotate them and they land on themselves. So there are rotocenters for this particular strip pattern, for these strip patterns, that are located somewhere between these vertical mirrors. And I'm going to go ahead and add them to the picture. So here where the rotocenters are, they're these little red circles. The rotocenters are located between the feet that are heel to heel, and they're halfway between those feet. And the other thing that is important to understand here is that what's going on is that these rotocenters are exactly half the distance between the 2 vertical mirrors, and they are located on the glide line. Again, we can see that in real time by rotating this set of feet, and it's clear that they're rotating around that little red dot. Down here, same thing happens. If I rotate these feet around that little red dot, they land on themselves. So this particular kind of a pattern, these patterns that don't have horizontal symmetry, but do have vertical flips, will also have half turns. So glides and half turns and vertical flips are a very important kind, but a very subtle kind of strip pattern. Now I want to look at the very last kind of combination of symmetries that a strip pattern might have. And so here is a typical strip pattern that has all 5 of our kinds of possible symmetries for a strip pattern. This particular strip has translations, horizontal flip, vertical flips, half turns, and glides. And again, I want to take the time to understand each and every one of them. The very basic kind of a building block is again this left foot, but it might be easier to think about it as a pair of feet, because if I have this pair of feet, I can easily see that the translation goes to there and then to there. But the building block itself is a little bit more subtle. What we really have are two pairs of facing feet. You can almost think of this as two dancers that are facing each other. And the translation takes the two dancers' pairs of feet. They have to jump to there, and then they jump to there, and then they jump to there, and then they jump to there under subsequent translations. Now, if I look at this pattern, it doesn't take a whole lot to understand and recognize that there's a horizontal line of symmetry, because if I reflect those top feet, I will get the bottom feet. So here's my line of my horizontal mirror. The top feet all reflect into the bottom feet. One thing I want to remind you of is that in the last video, we noticed that whenever there was a horizontal mirror, there always was a glide hiding inside, because a horizontal flip followed by a translation is a glide. And so what I want to do is I want to look at the glides in this one. Now if I just look at my basic set of 4 feet, if I do a glide on this whole set of 4 feet, this is what it's going to look like. I flip the feet, don't see much difference because this pair of feet reflects into that one and vice versa. And then I take these reflected feet and I slide them to there. Now that looks just like the translation on the surface. But it's important to understand that there's a subtle difference between how the translation and how the glide are actually working on the strip pattern. And I want to go through that quite carefully. And the way to do that is to think in terms of colors. So if I color this foot, when I do its glide, it's going to reflect down here and then be translated over to here. And if I look at how the glide works on this foot, it gets translated to here and then it glides to here. And if I look at this foot, it's first reflected to there and then it glides to here. And finally, if I look at this foot here, it's reflected there and then it glides to here. So it's important to understand that in the glide, the yellow foot goes to the yellow foot, the green foot goes to the green foot, the blue foot goes to the blue foot, and the purple foot goes to the purple foot. In a translation, this yellow foot goes to this blue foot, this green foot goes to that purple foot. Now, once we see how the glide works, it's also easy to see that the length of the glide is from these feet to these feet, because the whole set of 4 feet is moving into these 4 feet. In other words, the glide and the translation have the same length. But it's important to understand that the way that the translations and the glides act on the strip are very, very different. The translation takes top left feet into top left feet, top right feet into top right feet, bottom right feet into bottom right feet, bottom left feet into bottom left feet. The glide, on the other hand, takes top left feet into bottom right feet, and it takes top right feet into bottom left feet. It takes bottom right feet into top left feet, and it takes bottom left feet into top right feet. In other words, the tops and the bottoms of the patterns are swapped. In the glide, these 2 top feet wind up on the bottom, and on the translation, these 2 top feet wind up moving to 2 other top feet. So let's get rid of the colors so that I can talk about some more obvious kinds of symmetry. And what I want to notice is that this particular kind of a pattern has some very obvious vertical symmetry. If I look at any vertical line drawn between pairs of feet where the toes are adjacent, the whole pattern is going to reflect across that line. Likewise, If I draw a vertical line between two pairs of feet where the heels are next to each other, this set of feet will reflect to that set of feet, and same thing on the bottom. This set of feet will reflect to that set of feet. So we have a lot of mirrors, and now here I've drawn the vertical mirrors. And it's quite easy to see that they're vertical mirrors. If I look at these 2 feet and I reflect them over this line, I'll get that. If I reflect these 2 feet over this line, I'll get that, and so on. And if I take any mirror like this one, this half of the strip will reflect to that half of the strip. But I also want to notice that there's something more subtle going on as well. If I look at this set of 4 feet, I can rotate them in a half-turn rotation, and they land on themselves. And the rotocenter is the intersection of the vertical mirror with the horizontal mirror. And when I do this rotation, it turns out that this whole half of the strip will land on that half, and that half of the strip will land on this half. But I also want to notice that there's another place where I can rotate. If I look at a set of 4 feet that are toes to toes, and I rotate them around the intersection of the 2 mirrors, they also will land on themselves. So it turns out that all of the intersections of the vertical mirrors with the horizontal mirror are going to be rotocenters. So let's draw them. And just to reiterate, if we have a set of 4 feet that looks like this, clearly we can rotate them around that intersection point. On the other hand, if they're heel to heel, we can still rotate them in that particular fashion. So what we have here is a strip with a lot of symmetry, and I want to kind of summarize what we have actually found. First of all, because of that horizontal flip, and the fact that we have translation symmetry means that we have glide symmetry. And in a strip pattern with horizontal symmetry, the basic translation and the glide are going to have the same length. They move the strip in very different ways. Second of all, if we have both a horizontal line of symmetry and vertical flips, the intersection points turn out to be half-turn rotocenters. It also turns out to be the case that if we have half-turn symmetry and horizontal symmetry, then we will have vertical flips. And that's because if I do a horizontal flip followed by a half-turn rotation, it's the same as a vertical flip. So in conclusion, what we see is this upshot. If we have a strip pattern that has a horizontal flip, we cannot have exactly one of vertical flips or half-turns. If we've got a strip pattern that has a horizontal flip and we can find a vertical flip, the pattern's going to have half-turns as well as glides. Likewise, if we have a strip pattern that has a horizontal flip and a half-turn, the pattern is going to also have vertical flips as well as glides. In other words, a horizontal flip plus either a vertical flip or half-turn means that the strip will have all 5 kinds of strip pattern symmetries.